In this video, we're going to study the absolute value function and its graph. So what we want to start off by doing here is figuring out this thing called the absolute value function. All right, and the parent here is f of x is equal to the absolute value of x. All right, now whenever you have a new parent, the first thing you want to do is you want to start to think about what does it look like graphically and what are some key components of this. All right, so first thing I want to do is I'm going to make a t-chart here. All right, and the t-chart here will provide us with some things that we're going to refer to as critical points. Okay, the first thing is if I substitute a 0 in for x. All right, so again, I'm thinking of y equals the absolute value of x. That's another way to write that parent. When I plug 0 in for x, I get 0 for y. All right, which gives us the point 0, 0. What happens if I move to the right from that point now? If I plug a 1 in, absolute value of 1 is 1, giving me the point 1, 1. How about if I plug in 2? Absolute value of 2 is 2, giving me that point. And now I start to recognize that a pattern is emerging, and therefore I can sketch this graph for one side, at least, from that first point that we chose. Now, what if I look to the left of that? Well, the first x value to the left of 0 is negative 1. The absolute value of negative 1 is 1, which gives us the point negative 1, 1. All right, let's look at another point. What if I look at negative 2? The absolute value of negative 2 is 2. And again, I notice a pattern that begins to emerge. And what that pattern tells me is this is what the other side of the graph is going to look like. Now, each of these different sides of the graph, along with that point where the direction changes, all have unique characteristics. The first thing that we want to talk about is what is this thing that is known as the vertex? Well, the vertex is where that directional change occurs, and in the absolute value parent, the vertex is at 0, 0. Now, this is going to be kind of difficult to explain on a video, but hopefully you guys will understand it. From the vertex, I know that the points to the right go 1, 1, 2, 2, 3, 3, and that pattern continues. To the left of the vertex, it goes 1, 1, 2, 2, and 3, 3, and that pattern continues. All right? This creates for us something that is known as an axis of symmetry. I'm using a highlighter here to show it, but this axis of symmetry is a way for us to fold this graph over this line so that we get exactly the same graph on both sides. All right. In other words, symmetry occurs. Now, we call this line the axis of symmetry. I'm going to abbreviate it A of S, axis of symmetry. The axis of symmetry is always x equals the x value of the vertex. So in this case, it's going to be x equals 0. Okay? So the axis of symmetry we just talked about right there, that's that vertical line that splits the absolute value, creating symmetry. We talked about the vertex. Now you're going to hear us use the terms maximum or minimum, okay, when we're dealing with that as well. If you were to look at a textbook, this is how a textbook is going to define for you the family of absolute value functions. All right? In other words, here's what they're doing. They're taking the parent. They're saying, what's it going to look like if you move it up, down, right, left, flip it over x, flip it over y, stretch it, or compress it. Now, we have already studied those translations in one of our previous videos. So let's kind of take that idea now, and this is what is known as general form. I, again, really don't pay attention to it. I look at the actual equations. Now, when you are dealing with the equation, remember, everything is based on how it is different from the parent. So the parent we know is supposed to be y equals the absolute value of x. In this first one here, y equals absolute x plus 1. It's not the same as the parent, but it's similar. I can determine the transformation that occurs just by looking at it. And here's what I notice. This is saying plus 1 on the outside. That means up 1. On the second one, we've got plus 4 on the inside. Now remember, inside means right or left, and it's the opposite of what you think. So plus 4 really means left 4. How about the next one here? We've got x minus 1 on the inside and plus 3 on the outside. Well, the minus 1 on the inside is saying right 1. And then the plus 3 on the outside is saying up 3. Without graphing these, I can tell you that the parent is still the same graph, but it moved right 1 and up 3. What do I mean by that? Each and every point on the graph moved right 1 and up 3. How about this next one? Plus 6 on the inside means left 6. And then minus 1 on the outside means down 1. Now, what if we have numbers in front? Numbers in front tell us stretching, compressing, or flipping. In this first one here, we have 3. Because 3 is greater than 1, I know that this is a stretch of 3. This next one here, I see a negative. Immediately when I see that negative in front, I think flip over x. But now I need to deal with the 2. Not only is it flipping over x, but it is also stretching 2. So let's talk about what stretching means. Stretching means that if a point is normally at 1, 1 away from the vertex, it's now going to be like for a stretch of 2, it would be at 1, 2 up. So that V got skinnier. Okay, that's what stretching does. For a stretch of 3, instead of 1, 1, it would be at 1, 3. Okay? All right, let's look at this next one. Negative 1/2 absolute of x. The negative tells me flip over x, and that means over the x-axis. But now I've got this 1/2. When the value in front of the absolute is between, or in front of any parent for that matter, is between 0 and 1, this is called a compression. So it's going to compress 1/2. What does compression mean? Well, think back to the parent. Again, I know this might be difficult, so it might not be a bad idea, guys, to go ahead and graph these on a graphing calculator to see how they compare to the parent, okay? But a compression of 1/2 means this. If a point is supposed to be at 1, 1, that point is actually at 1, 1/2. It's halfway to that 1. Another way to look at it would be instead of going right 1, up 1 from the vertex, we could go right 2, up 1. That's also considered a compression. What a compression does is it kind of flattens the graph. All right, so it makes it get fatter. Stretch, skinnier, compress, flatter. Look on some graphs to kind of see if this makes sense. All right, let's look at this next one. I have a 1/3 in front, so that's telling me to compress. And I'm going to compress by a value of 1/3. Again, what does that mean? The vertex is still at 0, 0. But instead of a point being at 1, 1, the point is at 1, 1/3. Or another way to look at it, instead of the point being at 1, 1, the first point is at 3, 1. I know this is difficult to do mentally, guys. So again, don't hesitate to go and use some graphing utilities. All right. This one, they want us to do the same thing, but now they want us to take it a step further. They want us to identify the transformations, but then they want us to tell what's the vertex and the axis of symmetry. Very easy if you understand movements. The only thing that's going to affect my vertex, is right or left affects the x, up and down affects the y. So when I'm looking at these equations, the first thing I want to do is focus on left, right, up, or down. So in this first one, I know that the plus 2 is saying left 2, and the minus 4 is saying down 4. Now, those are the only movements that we have, so I'm going to go now and identify the vertex. The vertex is supposed to be at 0, 0. If I go left 2 and down 4 from 0, 0, I'm at -2, -4. There's my new vertex. I know that the axis of symmetry, A of S, has to be a vertical line, x equals, going through the x value of the vertex. And that's it. All right, let's take a look at this now. -6 tells me that we are going right 6. We are not going up or down. Okay? But I also have a 3/2 here. 3/2 is greater than 1, so we're going to say that this is a stretch of 3/2. All right? Now we're going to find the vertex. Right or left, up or down affect the vertex. So if it's right 6 from 0, 0, we are now at 6, 0. And the axis of symmetry, don't make it difficult, is going to be x equals 6, the x value of the vertex. All right, let's take a look at this next one here. Now this next one, they're trying to kind of mess with you a little bit because they kind of wrote things a little bit out of order. There's nothing wrong with rewriting this, but this is how it would be rewritten. Negative absolute x plus 2 plus 4. This, I feel at least, makes it easier to read the right, left, up, down, flip, stretch, or compress. All right. So for this particular problem, we know that it is saying left 2, up 4. That's going to tell me where my new vertex is. There's one other movement in here, and that's the negative in front. So I would say flip over x. Vertex was at 0, 0. It's now left 2 and up 4 from 0, 0. So that's the point, -2, 4. Axis of symmetry would be x is equal to -2. All right, and let's try this one. Plus 6 on the inside tells me left 6. There's no up or down movement. The 3 in front is telling me stretch of 3. That does not affect my vertex. That affects the other points, but not the vertex. The vertex, where is it at? Well, if I go left 6 from 0, 0, I'm at -6, 0. And that means that the axis of symmetry would be at x equals -6. All right, so one last thing to do here is, what if they give me a picture? And from the picture, they want me to write an equation. The first thing that I want to do is identify where the vertex is. I recognize that the vertex is at, let's see, 2, 3, 4, 5, 1. So the vertex is at 5, 1. I'm going to start with my parent, y equals the absolute of x. First thing I'm going to do is represent, how do you go right 5? Well, that would be x minus 5 inside. How do we go up 1? That's a plus 1 on the outside. Now, that's a good start, but we're not all the way done. What this graph should do, look up here at the vertex, is it should go right 1, down 1. It doesn't. Right 1, down 1. That's where the next point should be. It's not there. Instead, what's going on with this particular graph is we're going right 1 and then down 2. All right? So there's a couple other observations that I'm noticing here. All right? Number 1 is this is a flip over x. So a flip over x means I'm going to put a negative in front. I also know that this graph is getting skinnier from the parent. So if it's getting skinnier, that's a stretch. And instead, or because instead of going 1, 1, I went 1, 2, or 1 down 2, I know it's a stretch of 2. So now we're going to bring that in to where we're at. I have y equals -2 absolute x minus 5 plus 1. This is the equation of that graph that they just gave me. It takes a little bit of time and effort, but it's not really that difficult. It takes time to get used to, though. I'll give you that. Let's do this next one. The vertex is at -2, -6. All right? Start with the parent. Y equals the absolute value of x. I know that this means y equals absolute. If I go left 2, that's represented in the equation as +2. If I go down 6, that's in the equation -6. Now again, I look back from the vertex. I'm supposed to have a point 1 to the right, 1 up. 1, 1 from there. It's not there. The first point that I can see, like it looks like it's about halfway. I'm going to double check that. If I went right 2, up 1, there it is. Now I'm back on the graph. So I know that this particular one is a compression of 1/2. How does that affect the equation? It goes in front. 1/2 absolute x plus 2 minus 6. Good luck. This is going to take some time. Let me know if you have any difficulty, and we can try to set up a little Google Meet if necessary.